right, welcome all to our backup recovery office hour session today. My name is Timothy Chen. With me is Marco Calmasini, and we're here to give you an update on Recovery Appliance release 19.2.112. And so this is our latest release. It was out last week, and our agenda today will just go through the new features, okay, the highlights here for expanded replication, smart incremental, and archive log backup grouping. Marco is going to provide an update on archived ZFS Storage Appliance with Recovery Appliance for long-term retention. Then we'll have some time for Q&A at the end. You can also put your questions in the Q&A chat, the Q&A form there. So just to set the sort of stage for these first set of new features, I want to cover Recovery Appliance replication, just kind of give you an overview of how that's done today. Right? So replication is the ability to enable high availability and disaster recovery architectures with the appliance. And we have various topologies that are supported with replication, and you can kind of see a few examples here. We have the typical one-way replication, replicating from an upstream RA to a downstream RA, as well as cascaded from a downstream to other RAs. Okay, so this can be set up any kind of one-way and cascaded fashion. We also have this bidirectional replication. This is a scenario where you have databases that are backing up to the local RAs on each site, and the respective backups are then replicated to the other RA. Right? We call that bidirectional because you have a replication server on each of the appliances pointing to the other RA. The last configuration here is what we call hub and spoke, and this is a more sophisticated configuration, but in this case we have a local recovery appliance for each of the databases, and they're all replicating to a central hub recovery appliance, as you see here. Any of the recovery appliances, including the downstream appliances, can archive to cloud or to our tape, just with our normal policies that are available. The other thing about replication, which is very kind of innovative to recovery appliances, is that the upstream recovery appliances are aware of backups on the downstream, meaning that if a restore is needed by our man on those local databases on the upstream, the recovery appliance will actually fetch any needed backups for that request if needed from the downstream. For example, you might have a 30-day retention on the local recovery appliance. You might have a 90-day retention on the downstream. And if you need to restore to, say, 80 days, the upstream appliance will automatically forward that request to the backups on the downstream because those have longer retention. Okay? They might not be available anymore on the upstream. So it's got a lot of good use and benefits. We typically promote this for all customers for DR requirements. So what's new here in 19.2.112 software release is the expanded replication configurations that are available. Let's start with backup anywhere. Right? This new capability allows two recovery appliances to synchronize their backups for the same protected database in a replication pair. And what do I mean by a pair? Is simply bidirectional replication configuration. You have a replication server on each of the appliances pointing to the other RA. Now, backup anywhere does not require any new parameter settings. It's actually enabled by default. And what is new in 19.2.112 is that the databases, say your Frankfurt database in this case, is enrolled right in both the local RA and in Munich's RA. Those backups are replicated to Munich. However, those backups on Munich are not then re-replicated back to Frankfurt, right? And that's a big difference, obviously. The circular replication issue we've seen with some customers come about, where you have the same database and a policy added to a rep server going back to the same RA, the upstream RA, and that can create obviously issues. That does not happen anymore with 19.2.112 with backup anywhere. The use case this can be very suitable for is you have an outage where the say on the Frankfurt recovery appliances goes offline for patching or some other maintenance or issue, the Frankfurt database backups and redo are redirected now to Munich's RA. So you now have these backups continuing with level ones and redo transport with virtual fulls created and full recoverability on Munich. Okay. When the Frankfurt recovery appliance comes back online, then your Munich recovery appliance will automatically replicate its needed backups to synchronize Frankfurt. So this backup anywhere capability knows essentially the gap that exists after a period of outage or some other downtime, and will automatically know which backups to push from the downstream to the upstream. So there's going to be a reconciliation between the two catalogs, and then the needed backups are pushed or replicated back to the upstream. And then your backups on Frankfurt can resume now to its local RA, just like normal. So you don't have to wait for the synchronization to finish. The backups that are needed for the replicated backups that have not yet been transferred, but are needed by new backups, they'll be ingested, and the new backups will be in ordering wait until those replicated backups are available as virtual fulls. The other use case for backup anywhere is we have a data guard configuration, and you want to be able to offload the incremental backups to a standby database. This is a common configuration. We have this with RMAN for several years already, where essentially you have resources, you have backup storage, needs or whatever, and you want to offload backups from a primary. Or you can choose just to have the backups done on the primary, for example, and not done on the standby, right? Only on one of the databases in this case. So in this case, we have a standby database in Munich that's taking the backups to the RA. Those backups on the standby are interchangeable with the ones on the primary because a standby copy is a bit-for-bit copy of the backups. And you have replication set up from the standby side RA on Munich, and it's replicating to Frankfurt, as you see here. Now, when a failover or switchover operation executed, you have a role transition happen. So you now have the new primary on the Munich center, and you have the new standby on the Frankfurt, right? You have the redo now going the other direction. Backup anywhere will allow you to have the replication now reversed from the new standby RA to the new primary RA, right? So you have the change here that no initial full is replicated when that replication reverse. That's what happens without 19.2.1.1.2. Because there's awareness again of the backup state on both of the appliances, we only need to send the level ones that are needed and all just the needed archive log backups. Okay. So that saves you time and WAN consumption when the replication is reversed here. Also want to speak to a new capability called replication request mode. And this capability allows a recovery appliance in that pair to automatically fill a recovery window gap, maybe because it's been out or some other kind of issue from the RA in the replication pair. So it sounds kind of similar to our backup anywhere that I just showed you, but there is a difference here, which I'll go through. In this configuration, we have data guards, and we have a setup where we have a local backup being taken on Frankfurt to its RA and a local backup on Munich to its RA. We have the replication servers configured in bidirectional replication, as we referenced before. You're going to add the rep server to the Munich RA's protection policy, with those databases that have to be replicated as normal. And you do the same on the Frankfurt RA. However, on the Frankfurt RA's add replication server API, you're going to specify this new parameter, call it request only equals true. And what happens here is that there is no active replication that will be set up, that will be happening between the Frankfurt and Munich RAs. But the CAD logs in the Frankfurt site RA will be kept in sync with those standby backups being taken in Munich. So we're going to have the internally the CAD logs that are available, even though the physical backups are not on Frankfurt. When you have an outage or some kind of patching event, your standby backups will continue to the Munich RA with full recoverability. So you can also, restore from that standby, because again, the standby backup is a bit for bit copy. And when the Frankfurt RA comes back online, request only mode will kick in, and it will request the backups from the Munich RA to synchronize. It will request those needed, and the underlying kind of synchronization awareness capability that we have, it'll pull those over. The backups can then continue from the primary RA in Frankfurt, and the replication during the request mode will eventually end when all the needed backups have been transferred over. Right. So if you have log deletion policy set up on Frankfurt, for example, to that local RA, you're going to be using now the shipped policy or shipped to standby, all standby policy, to determine whether a log can be deleted or not. You may also, secondarily, decide you want to continue taking your level ones and redo to the standby RA. Note that this will be duplicate or overlapping backups now taken to the Munich RA. That can be done, and you can have the deletion policy still set up to be backed up to all standby, for example, and then the resync will happen when the primary RA comes back online. But just note that you're going to have additional storage, network consumption, et cetera, on that standby site RA. All right, the last thing I want to cover here for new replication configurations is called read-only mode. And this is a situation where you want to, say, migrate from old RA hardware to new RA hardware. And read-only mode allows a downstream RA backups to be set to be read-only access from the upstream. And let's see how this works. In this case, we have a Frankfurt databases back in locally. This is our existing RA. You have a new RA that is going to be set up in Stuttgart. So you're ready to start this data center migration process. And so your databases will first be cloned to Stuttgart, and you can do that with the backups from Frankfurt, where you can restore across the WAN, because these RA supports that restores from any location. Your new RA hardware is in place in Stuttgart, and you want to now set up a replication server from Stuttgart to the Frankfurt RA. The Frankfurt RA does have still the current backups and the history of backups to satisfy its recovery window goal. And you set up that, you add that replication server to the protection policy with read only equals true. That's the new parameter. That will allow the backups on the downstream to be readable for any restore purposes from Stuttgart. The backups on the Frankfurt RA will continue to be available until they're obsolete, as per the recovery window policy. And when they become obsolete, that Frankfurt RA hardware can be decommissioned. Your Stuttgart databases will continue to, will take the new backups and redo to the local RA, just like normal, and the current recovery window will be satisfied from that new hardware. Let's move on to a new capability we call Smart Incremental. Right. And this capability was designed to eliminate virtual full creation issues due to ordering wait incidents. And some of you might be familiar with this incident in the RA log. These incidents arise due to missing backups on the appliance. For example, incremental backups have been erroneously taken to a different disk or tape destination outside the RA. Okay. You might have had an old script that's used or something like that prior to using the RA strategy. So those backups don't exist on the RA. And ordering waits occur because there's a new incremental that can't be tiled on top of any existing virtual full that should be there. Okay, so the metadata might be there with the catalog, but the physical backup is not there. And that's why you get the ordering wait. And typically we tell customers to take a new level 0 if they see these ordering wait operations, and that's a manual task. And with the smart incremental, the RMN session will communicate with the appliance to determine the incremental blocks needed to create the virtual full based on whatever is current on the appliance. So it will not consider backups outside the RA were just taken outside to a disk or another tape destination. It will look at its own local backups and then communicate that back to the RMN client saying, here's the incremental backup you need to create in order to continue this incremental forever and virtual full strategy. All right. So everything remains the same. There's no new parameters or anything else that has to be set. It's enabled by default on the RA. It's available to all supported database versions and RMN clients. Does not require a new RMN or patch or any kind of DBMS side patch there. And just like we see before, all incrementals will just be created now without these ordering wait incidents arising due to these issues. The other thing that Smart Incremental will enable is automatically preserving virtual full creation in the incremental forever strategy when you have new TD databases that have been moved to TD, existing TD databases that have been rekeyed, or you have key rotation events. These all require today a new level 0 to recovery appliance. And there are cases where a DBA and an RA admin are in two separate groups, right? Two different roles. And the RA admin does not know when TD has been enabled or when rekey operations have been done by the DBA, and they suddenly see these incidents like encryption key mismatch and so forth, right? So the smart incremental, what happens here is that it will send the level 1 just like normal to RA. It'll internally get that message that encryption key mismatch has occurred. And the client will then know to send a new level 0 in this case. And that will then resolve that situation and continue the virtual full backup. So essentially no user intervention is needed now when you have a new TD or rekey operation happening. All right, finally, I want to talk to archive log backup grouping to cloud and tape destinations. The intent of this capability is to reduce the time for copy to tape operations, minimizing network round trips, and especially device contention. Some of you might be using tape today for longer term retention needs from the RA. And today, when you use real-time read to transport, that is converted into individual archive log backups on the appliance, one backup per log. When those logs are copied to cloud or to tape, they're copied one backup file per stream, going to those destinations. And especially for tape, that can result in prolonged operations for heavy log volumes, especially because tape has physical mechanics involved with moving the tape, positioning the tape, seeking, and so forth. Every time a log backup comes in, it's another job that has to be processed on tape. So this can take more time or take a lot of time for these logs. With 19.2.1.2, the system will automatically now group these logs in larger backup sets per stream. The default is 64 with a max of 8 gigabytes per backup set that is grouped. And this is done by the RA prior to copying those logs off. And this results in more efficient operations, completing in less time. So again, no new parameter or no any other changes needed on the database side. This is just an upgrade to 19.2.1.1.2. Now I'll just pass it off to Marco to now cover the update for Recovery Appliance Archive to ZFS support.
Yeah, thank you, Tim. Okay. All right. So what we're going to introduce today is the ability to use ZFS Storage Appliance for long-term retention backups offloaded from ZDLRA. So in addition to tapes and the OCI public cloud, which is what we support until today, now we also add the ability to use the or a ZFS Storage Appliance. This is done through the ZFS Storage Appliance Object Storage Interface. So we are going to use from ZDLRA the same OCI REST APIs to send and read data to and from ZFS. This provides investment protection for customers that already have ZFS, already invested in ZFS, and they also have the recovery appliance. It is also an effective solution for customers that don't want to use tape and don't want or cannot use the OCI public cloud or public cloud in general. The backups sent to the ZFS storage appliance, like it happens for cloud buckets, are in standard native RMAN format, so they can be restored also without the recovery appliance. And in some tests that we did, we were able to reach almost wire speed when reading and writing to ZFS. We had a kind of average throughput 24 terabytes hour natively, and you basically almost doubled using compression, using the 25 gigabit Ethernet ports, both on recovery appliance and ZFS. So the workflow is similar to what happens with the OCI cloud. We have protected databases here on the left that, as normal, continue doing their incremental forever and potentially real-time transport to the recovery appliance. When a backup needs to be copied to ZFS, the recovery appliance will encrypt it. It will use Oracle Key Vault to manage keys. So it will get a key, an encryption key from OKV, encrypt the backup, send it to the ZFS storage appliance bucket. In case of restore, again, as it happens from the cloud, protected database can initiate a restore connecting to the recovery appliance. Where these backup pieces are, it's totally transparent to the protected database. The recovery appliance will manage that. If the backup pieces needed are not locally stored on the recovery appliance, it will get the decryption key from the Oracle Key Vault server, get the pieces it needs from the ZFS storage appliance, decrypts them, send them back to the protected database in a totally transparent way. If you want, as I mentioned, you can restore directly from the ZFS storage appliance, even without ZFS. You need to install the database backup cloud module on the protected database. You need to configure it to point it to the bucket on the ZFS storage appliance. The database cloud backup module is the same module we use to backup to the OCI buckets. So you configure it to point to the recovery appliance. You can restore directly from there. As the backups are encrypted and the keys were stored in Oracle Key Vault, you need to either enroll this database as an OKV client or endpoint that is called. It's called an OKV terminology, so that it can get the decryption keys it needs, or you can export the virtual wallet from OKV into a file type wallet. You copy the file wallet to the database you're restoring to. You configure it as the TDE encryption wallet for this database, and so that when you can do a restore, Armor will find the decryption keys it needs to be able to successfully decrypt the backup and restore them. Okay. To configure this feature, we use exactly the same process we use for the OCI public cloud. First of all, obviously, you need to configure the OCI object storage service on ZFS. And then you go to the recovery appliance, you configure OKV as documented in the ZDLRA admin guide. And then you created the 3 configuration objects that we use to set this up. You create the cloud key object using the array CLI, add cloud key command in ZDLRA. This is needed to create the authentication key. So it's not related to the encryption keys I mentioned and the OKV thing. This is just the key pair used to sign the API calls and basically authenticates, right? Both against OCI or ZFS in this case. So you either create a new key pair or you use an existing key pair. In that case, you have to provide the private key. And yeah, you create this cloud key object on ZDLRA. Then you create the cloud user object, which is basically specifying the user that you're going to use, the tenancy, the compartment you're going to use, and obviously the cloud key that you want to use that you created previously. Once you have the cloud user created, you can create the cloud location. And the cloud location is actually the bucket and the destination ZFS appliance that you will be connecting to. Once this is all done and you are able to access the bucket on ZFS, you can go ahead and create the SPT job template that defines what needs to be copied from ZDLRA and when. And that can be done either through Enterprise Manager or using the DBMS RA CLI commands. On these two commands, so the one used to create the cloud user and the one used to create the cloud location, there are some specific parameters that differ a little bit when using the ZFS compared to what happens when you are in OCI, and I will highlight them in the next couple of slides. For more details on this process, here I find the links to the ZFS documentation where it's explained how to set up the object storage service. The Oracle Key Vault documentation in case you need more information from Key Vault, but the basic things needed to use it with ZDLRA are also documented on the ZDLRA admin guide, which is linked here. And then there is a must note, that is this one, that go into more details on the things that I'm going to explain in a moment. But you will find all the details on this process with a lot more information. So few things that I want to highlight now. Again, I will not go through all the details of all the commands and what the output looks like, etc. You will find that in the must note, but just to highlight some important things, I believe. So one thing is that when you go to the ZFS console, the web console, and you enable the OCI object storage, you see this OCI API mode, you will see this URL listed here. This is not the URL that you have to use when you run the add cloud location command. You don't need to include the last part, which is export/file system. You can stop at OCI. That's the endpoint that we are going to use. The file system or the share name, okay, so export/file system, and ZFS is used both as storage namespace and compartment OCID. At least we will use it as compartment OCID in our commands. Storage namespace does not need to be specified in our configuration commands, so you can ignore for now. We get it automatically. So here are the real differences compared to what happens with OCI in the public cloud. So the user OCID, right, that's used by the RA CLI add cloud user command, is a little different. So in OCI, if you're familiar with the OCI OCIDs, these OCID are just resource identifiers that we use in the OCI APIs. I was saying in OCI, they all have this format. The first part up to OC1 ... is fixed, and then you have a kind of long string of random characters. In this case, with the ZFS, this OCID is just the ZFS username. Okay, so this is actually the ZFS username that owns the file system that we are going to use to store our bucket in. Okay? It's always like this. On the other commands, command that you have to use, sorry, take it back. The other thing that you specify when you run the RACLI add cloud user is the tenancy OCID. This is fixed, never changes on ZFS. The tenancy OCID is always this one that you see listed here. Okay. The compartment OCID, as mentioned before, it's actually the share name. So export/file system name. Okay, that's what you have to use when running the RACLI add cloud user as compartments OCID if you are targeting a ZFS storage appliance. The next command now, finally, that you have to use is the RACLI add cloud location. Here you specify the host parameter. The host parameter is the ZFS host name or IP address, and it's a URL. It looks like this, right? So HTTP : ZFS hostname or IP address /OCI. Make sure you use the right IP address or host name here, not pointing to the admin interface or something, right? So you want to use the right high-speed network that you have available. The other thing, do not use HTTPS. That will get you some additional work to do to figure out how to set up certificates, etc. Sorry, the backups are encrypted, so you don't. Everything that travels on the network is also encrypted. So you just use HTTP, and it's easier. The same type of parameters must be used when you configure or use the OCI install.jar Java installer, which is the installer tool for the database backup cloud module. This is what you need to install on a database server if you want to restore directly from ZFS. Okay? It's not needed to backup or restore through the recovery appliance, even if the backups end up being in ZFS. If you go through the recovery appliance, this is not needed. But if you want to restore directly without the recovery appliance from the ZFS appliance, you need to install it, and you need to use the same logic when matching the ZFS parameters compared to what it would need for OCI. Okay. Once you've done, so once the RACLI add cloud location command completes successfully, you can go to Enterprise Manager, and you will find that that command also created a new media manager. Media management library takes always this name, which in the end it's bucket name based on the bucket you specified _ username. Okay? It's seen as a cloud destination. And in addition to this, it also creates a number of attribute sets. These attribute sets are created based on the number of streams that you specify on that command. And these are used to determine how many streams you want to use in parallel, for this specific job that you have to create in the next step, which is this one. So you go to the create or to copy to media job template in Enterprise Manager, and you create a new copy to media template. You specify the media management library that we just saw. And you specify an attribute set. This is what determines the amount of streams. You see _8 is specified here. It means that this job will use 8 channels in parallel. You define the scope, can be either a protection policy. So in this case, this job will apply to all the databases backed up through these protection policies, the policy in ZDLRA, or you can limit it to a specific database if you want. You specify the backup type, can be full, incremental, archive logs, or the combination thereof. And you specify a compression algorithm, you want to use it, and an encryption algorithm, which is required. Here you can now run it immediately or schedule it, and it will run. Like, if you want to copy every weekend full backup to ZFS, that's how you do it. Okay, you specify full, you schedule it for every Saturday or Sunday, and that will just do that. The other thing that you want to do is go to the protection policy. So in this case, we're looking at the protection policy that is job template applies to. And this protection policy, you have a media manager recovery window policy. This is where you define for how long you want to keep this backup. So this is your retention time, basically. So the backups copied through this template that applies to this protection policy will be stored on ZFS in this case, but it's the same process also for cloud for 14 days. And you can set up the amount of time you want. The last thing I want to mention about this is that now the fact that you can integrate ZFS with the recovery appliance You can also look at using an OSP environment or the Oracle Secure Backup, which is the Oracle traditional kind of backup software that can back up also file system on heterogeneous environments. So you can use it to combine and create groups or group backup that span also multiple servers or database servers that include database backups sent to the recovery appliance as incremental forever, and file system backups. So it can include other type of file system data that in this case will go through the an OSP media server to the ZFS as well. So you can combine database backup and file system backup and have Enterprise Manager control and orchestrate those as a single group job, if you want, or single operation. Okay. Supported versions. So to do this, you need to use the ZDLRA software 19.2.1.1.2, which is what we've been talking about. ZFS OS release 8.8.27. You need Oracle Key Vault to manage the encryption keys. That's a requirement. At this time, only Linux and Windows protected databases, so small endian databases, can be copied from ZDLRA to ZFS or the OCI public cloud. It's the same thing. We use the same infrastructure, and we have this limitation in both cases. If you need to do that for other databases like Solaris or AIX or HPUX, etc., or big endian databases, just reach out to your Oracle contacts, and we'll try to help you. One last thing I want to mention: there is no archive storage tier on ZFS like there is in OCI public cloud. It would probably make too much sense in ZFS. So do not use these options or the options for archiving when setting up the cloud location, because those would not work. They're not supported on ZFS. Okay. So I think that's all I have for today. If you have questions, feel free to ask. Look at the Q&A. I don't know, Tim, if there's any question or anything you want to highlight. Otherwise, I'll just hand over to you.
Okay, yeah, thank you for that, Marco. Looking through the chat questions, and Kelly's been answering them as I have. Nothing is, let's see, it's open. Let me see if there's one open here. There's one that on EM, historical templates information. I think Kelly is answering that. Kelly, do you want to bring that one up?
Yeah, I can talk about that real quick. So obviously we add functionality in later version with all the versions of EM. So we have plugin updates, we have updates that go into each version of EM. Historical information is stored in Enterprise Manager. You can see that probably the easiest way to get to that is under protected databases. If you select your protected database, the details will show up at the bottom for the protected database, and then there's a backup report button from there. And if you click on the backup report button, which is on the right, it'll list out all the operations that occurred on that database, whether that be a backup or an archive off to tape or to cloud. It'll show the backup types, how much data was moved when it was started, and how long it took. So all that historical information is in the console. So that should be there.
All right, thank you, Kelly, for that. Let's see here. Yeah, go ahead.
And that's it. So I'll type that out real quick in the chat so that everyone has that information.
Okay. All right, just looking through other ones. We've all covered these. Okay. Okay. Yep, not seeing anything new that hasn't been unanswered. And so we're ready to close this session. There was a question to contact the PM team offline. If you go to the office hour session, there's a location to ask a question on that session. So you can actually log a question. They'll come to us and provide your email as well, and we can follow up offline with there. Okay. Documentation for the new version. Great question. This documentation will be available next week. We just had the software release done. The doc is getting its final revisions and finalization, and will be available next week. Yeah, if you want to check next week or the week after, please do so. It'll be under the same ZDLRA doc website. PPTs will not be uploaded to the office hour session, only the recording will be. If you do want the PPT, we could probably convert it to a PDF and get it to you. You will need to log a question again on our office hour session site. And then we can, with your email, and we can follow up offline. Okay, good questions. And thank you, Kelly, for answering. Well, I hope everyone has an enjoyable rest of your day and a good weekend. We will see you again on our next office hour session. Thanks.